this. I think I'm going to buy a tablet while I'm home. I've never had a real tablet before. Do you know what a good brand is? Like, I want to use the thing for Teams meetings and like being able to draw on it and shit like that. Hold on a second. It's telling me I'm not allowed to do this sharing thing now. It says there. Well, so yeah. Well, here's my deal, right? Like I'm old school. Like you're like half my age, right? So when I grew up and when I was a computer engineer and learning how to do computer science and hardware, creating hardware and all that stuff, right? Um, back then, there was a very distinct break or difference between Apple and PC, right? And this is my age speaking, but back then, like if you were an engineer or a power user, where you were a coder or you were a hardware guy or whatever, you had to use a PC. And the reason for it was because Apple never exposed any sort of development environment, right? Apple has always been this company that's like, um, you stay away from our shit. We're not giving you admin rights. You can't develop anything. Like you're just a stupid user, and we provide the hardware. And can you see my screen? It won't even let me like draw on here with the annotations. I don't know what the hell is going on with this. It says there's a problem displaying the content. Hold on. I don't know. We're just we're having problems today. But so I've always been very anti-Apple, okay? Because I don't like the ethos, like the mission statement that they have. However, I am open-minded, and I have not tried an Apple product since 1996 or something, right? Was the last time I used any Apple products. We had those stupid. You ever remember? You don't probably ever seen this. Let me see if I can find it. I got this shit Bluetooth keyboard I'm going to throw away. I have to. It shuts itself off, and I've got to like type on it 50 times to get it to turn back on and connect, and then type again. Like literally, it turns itself off after like a second. Anyways, I'm on really bad Wi-Fi at the hotel here too. This hotel is ghetto as shit. Come on. Anyways, back in the day, they had these stupid. You ever see this thing? Right? Yeah, this was like a spoof, right? They had the real one with computers that looked like this, and the whole point of Apple's deal was, the aesthetics of the computer sold it, not the actual functionality of it. And so somebody made this spoof of a vibrator, right? Anyways, so with all that being said, I'm willing to try it. The problem that I have though is compatibility. I'm concerned about how do I do this? Can you see this now? If I draw on here, can you see that? Okay. Yeah, my concern is compatibility. So it's got to work with Microsoft Teams, got to work with some of the other software that I use. But other than that, I don't care. I'm assuming the hardware. That's my understanding, is that Apple has really enjoyed an advantage in the marketplace the last 10 or 15 years because of ARM, right? They've got the high powered cheap processors that work really well, and their hardware is second to none, right? And everybody else, all these Windows based small machines and stuff that people had for a long time, they all went extinct. And like the Surface Microsoft Surfaces and all that stuff. Like they stopped making them, I think. So, and then they never were that good to begin with. So I was looking at a Samsung Galaxy Tab 10, I think it is, because it offers this it's called DEX. It's like okay, so you've used those before, that you know about this DEX stuff, right? Well, the thing that I need is something that I've got a laptop, right? I've got a laptop that's 1 kilogram, but it's still too heavy type of thing, right? Like uh it's big and it's heavy and it's hard to bring around everywhere. But a tablet, especially like a Samsung Galaxy Tab 10 or something, or one of these Apple, what are they called? The small the small tablets, is iPad Mini or something, or I don't know. Um, that you can bring with you everywhere. You just put it in your bag and it goes with you everywhere, right? But it offers me the ability to, if it's got the clamshell keyboard and all that stuff, I can log into my computer if I need to do heavy duty stuff. But I could check emails. I can do Microsoft Teams meetings. I need to be able to run Microsoft Office, right? Like Excel and Word and all that stuff. I don't know how you do that through um, Macintosh, because Andrew, the president of the SPWLA in Bangkok, he's like the exact opposite of me, right? He's like, he hates Windows, he hates Bill Gates, he loves Macintosh, he refuses to use anything but Apple's, and he can't use Teams or Windows applications like Microsoft Office. So you have like a virtual machine, right? Okay, well, I'll look around here. Yeah, because yeah, and I'll look around, and if you need anything either, let me know. Like, because a lot of electronics and stuff are way cheaper in the States. You can pick up really nice computers and tablets and things for less money, um, instead of having to buy it in Thailand and pay 30% more. But um, I'm gonna look while I'm here. I've got the 2 pound laptop. I've got the 5 pound Legion laptop, and now I need like a small tablet, but it's got to be super lightweight. That's the other thing. I don't want to have heavy. So I think the Apple or the Samsung 10 are what I'm focusing on, but I got to go check them out. But I'm not going to buy another laptop. I've got enough laptops. Anyways, so here's what I was thinking of doing for the frac thing, and we can button this up and send an email to Doug. What I was thinking was make like a plot, right? So we got a plot like this or something. We've got the geosteering profile of the well, okay? And we got the stages kind of marked on it. I'm just going to simplify this and say that we've got like, sorry, 5 stages or whatever. And so then, what I kind of want to do is make a visual, and we can just put the numbers on there, or if you want to get fancy with your Python stuff and do some wizard work, that's up to you. But I think it'd be cool. Hold on, how do I change the color here? So I'm thinking like, we got an ISIP value. We post that on here. You got like an ISIP. You got an indicator of the frac height from the ISIP, right, for each stage. So we got that model, and we kind of show, this is what that looks like, this is what that looks like, whatever. And then we also have the results from the hydrofrac, right, from the simulation, numerical simulation. So you kind of got like 2 bars on each stage to see, how different these are or something. And we've got a bunch of different numbers. I see that you've extracted everything for the hydraulic fracture simulation. So when you frac these wells, right, it creates, like this is your well bore, I guess, right? It creates a system in here where you have this 3D mesh, where it's actually, well, it is a 3D mesh because it has a wide component to it. But you get something that looks like this, right? This is physically what comes out of the simulator. So what it does is it does this. It says, you know, here's my perfs where the orange dot is. That's my perfs. So I've got like the height, you know, based off of these cells. It's going to have fill fractions, right? Like maybe that one's 100%, and that one's 100%. You know, this one's 50% over here or something, right? Although that technically should never happen, because if you look at these fractures, the reason they are the way they are is because there's rules inside the simulator that say that the height has to monotonically decrease from the wellbore to the tip, right? So if you got connected cells here at the wellbore, you cannot have like another cell over here that's connected where it goes, you know, can happen. Simulator prevents it, and that's the normal behavior, right? You don't get fractures that open up like this and then do something like that or whatever. That's not physically possible. Not at least in linearly elastic fracture mechanics and SNED and stuff. Hold on one second. I've got this room I'm in stinks really bad. I think people were smoking in here. Doesn't help that I just dried my sinuses out on a 20-hour fucking plane ride. Now I got to sit here and smell fucking mold and shit in this hotel room. Yeah, it's height. Stage, yeah. You would kind of center the perforations where this light blue line is, right? And you would have the height above and below, kind of like what you got. But you know, anyways, so this thing, the reason I'm showing you this is because, you know, you fill this fracture out. Every one of these cells has got a different width, right? It's not like, you know, and again, width, if you look at the width profile, there's similar constraints where it has to monotonically decrease. So like the simulator itself, it uses banding and strips and stuff. So it'll run like an algorithm across each layer, essentially from the wellbore to the end of it. And it says, in each layer, this criteria must be satisfied that the width of the fracture monotonically decreases. So you can't have a fracture that's like thicker right here, but then thinner over here. That can't happen, technically. Okay, let me finish. As long as you're using fluid during the pumping process, that can't happen. Okay, after you're done pumping, you can have sand settle out over here, for example. Like there's a big clump of sand or something, the fracture closes, and when it does that, essentially, this is all zero. This orange, right? This is all zero conductivity because the fracture has just disparity and nothing left. And all of your conductivity would be here. So if you look at your width profile, it's going to be like zero. You're going to have this stranded region between the wellbore and where the fracture sand is. But we're looking at something like this with the orange thing, and we want to determine what the height is, right? We don't really, I mean, the half length is good. We want to put that on here too. We want to, like, you know, put half length equals whatever. But the height is really what we're after because we're comparing it to that Sneddon model. And so how do you figure out height, right? Where do you get it from? So you know, this is going to happen in the fractured case, like in your spreadsheet there, I was looking at it, you have max frac height, hydraulic half length, propped half length, you know, height above and below perfs and stuff. I don't see the differentiation between these two cases, right? So you got this case here, and you got this case here. This is where the propped stuff is, right? So this propped height might only be like 60 feet. But the hydraulic height, and it also depends on when you look at the hydraulic height, time is equal to what? Is it end of pumping? Right? End of pumping is going to be your maximum hydraulic height. If you look at the end of simulation, the simulator HFRAC-R actually closes the fracture. So when it closes down, there's some minimum width criteria, right? Maybe it's something like that. It's 100 feet at end of the job. It's 200 feet at end of pumping, right? And then if you just look at the propped case, it's only 60 feet or something if you set a cutoff for a minimum conductivity value. Are you following me here on this part, on this connectivity part? Yes or no? Yeah, so, you know, when you, let me do this. It's this piece of shit keyboard. I ought to just buy a new keyboard, I think, and bring it back with me. Okay, so let's do this again. So here's what I'm saying about that. So like if you got a fracture, and again, you got these cells, right? Boom, 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 boom. Now, inside of these cells, pick a color, your favorite color, purple. We got values for conductivity. So conductivity is KF, WF, okay? And this is in units of millidarcy, which is where that's coming from. That's a conductivity of the fracture. This is why I want that tablet, right? So when I draw, it doesn't look so damn, looks like a zombie is drawing, or a dead person, right? Like it's not. So that's millidarcy feet. And this thing, they scale it, right? So that it's in feet, from inches or centimeters or millimeters or whatever. They change it to feet. So you get millidarcy feet units for conductivity of the fracture, okay? So you have like 1 millidarcy foot there, you got 20 here, you got 40 there, you got 10 there, maybe 100 here. There are all these different values across that fracture. So the question becomes, when you look at the Sneddon model and you look at, you know, live diagnostics, if you will, you run your thing, right? This is the well bore with the crack or whatever, okay? Fluid is flowing down that crack, and it's only flowing down, by the way, like I drew this sort of on purpose, because like there's a closed portion of the fracture, maybe looks something like that, right? Those are, there's no proppant in it, and it's not contributing to flow, right? This stuff here is just dead. You generated the geometry at one point in time, but you never propped it, right? And then this stuff inside of the fracture, the green, that's flowing because it's got sand in it, right? But here's the problem, and this gets a little bit complicated. Depending on the value that you've got in here, say that's 2, 3 millidarcy feet, whatever, like some of this fracture may not actually contribute to flow. Say it looks something like that, or whatever, where the blue is, right? It's actually, it's not, nothing's flowing in there. And the reason for that is because you have relative permeability curves. Well, actually, I'll tell you what, I'm going to undo that because that's wrong. I don't want to show you wrong things if I can get the stupid keyboard to work. Come on. Uh-oh. It won't undo. Do this again. But you got relative permeability curves. That's what they look like in a fracture. They're not curved. Straight soil. There's now, if you are, you know, at a certain point on that relative permeability curve, say we're down here or something. So there's like a 0% water phase. There's 100%. or oil or whatever, right? Like if we're on a certain part of that, we get fractional flow. And actually there's a, the capillary pressure of the proppant pack, you have to be greater than that value to have a flow greater than 0, right? If you can't overcome the capillary pressure, the water won't move. So there's a DP component to that and a bunch of other stuff. But anyways, my point is this: look at all of the conductivity may give us a height of say 350 feet. Okay, but if we actually run a conductivity cutoff and we say we're only going to talk about cells that have a value greater than 20. Right, to get rid of all these little bitty ones that have like 2 grains of sand in them or whatever. Then maybe our actual flowing height is 200 feet or something, right? And then if we compare that back to our this thing, right? Instead of having these gigantic values you've got in your spreadsheet, maybe they're actually smaller and closer to what we're seeing from the Sneddon flowing thing. So my point is, when I see 2 or 3 different items agree with each other, then I start to believe it, right? That's what's happening. And then the reason I want to make a plot like this too is because I want to look at from stage to stage, stage 1, stage 2, stage 3, 4, 5. We know if we look at that ISIP plot, right, we got like ISIP number 1 is low, and then it goes up, and then it goes down, and then it goes up, and then it goes down, and then it goes down, and then it goes down, and then it goes up again, right? So you got like this sort of thing going on. And I want to understand what the fuck's going on right there, because I think if we look at the geosteering plot, and we may have to talk to Doug too, we'll just use what he's got to begin with, because this is how these things go, right? We have to drive the show. The people at this company are not technical subject matter experts. They're operational people, right? They know how to drill a well and permit it. They know how to get the people out on location to frack it. They know how to tie it up to a separator. They know how to put a pump jack on it, and they know how to sell the oil. What they don't know is all the technical stuff. So what you have to do is paint a picture, even if you don't have the data. And if I just give them this drawing, right, where they understand it and they say, oh yeah, we got you. Right? Like if your well bore, let me just redo this again. Do another one. If your well bore looks something like this, where you're in zone and then you're out of zone, and you're in the, say this is like that L1 landing zone 1 at 9,000 feet. Okay. And this is 0.5 millidarcy, that upper lobe, right? We looked at those logs and we saw like there's the good one and then there's the real good one at the bottom. Okay. So that's that one, 0.5 millidarcy. And like the layers look like this, right? There's the upper layer, and then an upper layer kind of looks like that. And then I'll draw the other one. So actually, some of these states, yeah, I'm at a hotel, right? Hotel in the United States. Yeah, can you hear me now? Yeah, I'm just saying, like that's the upper layer, and this is the lower layer, that this second lobe, right? So I think we need to investigate whether or not the well bore steered into the lower layer, and these are the stages with the low ISIP, right? And it would have a low ISIP is if you look at the stress log, right? SH min stress log, it's high in the upper zone and it's low in the lower zone. Because as porosity increases, right? Poisson's ratio, we talked about this the other week, right? Poisson's ratio goes down. If Poisson's ratio goes down, stress goes down. SH min goes down. So we get lower stress pocket here. And we see that with your ISIPs. We know that the initial part of the well was landed. It's also possible, right, that all of this stuff that we're saying is just a bunch of bullshit. And really, the well is drilled in the upper zone. But in this part of the well bore, the permeability is like 2 millidarcies or something, because it's a carbonate, right? It's just better reservoir quality than it is on the sides. And we see this. But we need to paint that picture anyways of, this is why we're putting all the information that we have from the ICIPs, from the geosteering, from the logs. We're putting everything onto one plot to make it a story. Maybe it tells a story, maybe it doesn't, but this is the job, right? And I'm telling you this like, to sort of entice you, but if you want to work in this industry, if you want to work for PetroRes, going forward after this internship and stuff, like this is the kind of work that you're going to be doing all the time. It's detective work, right? You're taking data from all kinds of different things, and you have to storyboard it, right? Figure out what's going on as an engineer. It's really important, right? Because I mean, it's a mental model, and it's important that you have to understand all the pieces that go into it as well. You can't, as an engineer, you've got to learn where everything comes from, how it's interpreted and analyzed, and all these things, and then be able to communicate that to a client, to work with all kinds of data, right? We've already, since you started, right, you've already touched DFITs. We've got a frac job, we've got logs, we've got facies, we've got, core data, we got everything. That's how we operate. So anyhow, let's join the other meeting, but I just wanted to kind of go through that with you really quick so that you understood what I was after, and we'll talk about that later. Yeah.